Okay, so my name's Keith Still, and over to my right, which of course you can't see because this is all done on radio, is Kate Byrne. Kate?
Hi, my name's Kate Byrne, and I'm here to answer any of your questions via the Q&A and chat boxes. Anything on the materials covered today, please type them in and send to us so we can get those answered for you. We'll collect them all up, and at the end of this seminar, we will give you the answers. And unfortunately, due to the amount of you that are signed up, we can't take verbal questions over the phone. So once again, send these to all participants and all panelists via your Q&A and chat boxes and not to the host. Otherwise, I won't be able to receive your questions. Thank you.
Thanks, Kate. So this morning's session went particularly well. We've managed to answer a dozen or so questions that are already posted on the website. At the end of this session, we will be able to make a recording, so both this morning and this afternoon session will be available for download. And our aim is that you spread this information as far and wide as is possible. Okay, thank you. So a little bit of background into myself. I have a PhD in maths and psychology with over 25 years of experience across a wide range of industries, but about the last 20 years been focusing on the development of crowd science. I'm here at the UK Cabinet Office Emergency Planning College, where for the last 14 years we've been developing and teaching the principles of crowd science, crowd safety for major events. Also done some work at an international level, government consultant to UK, Holland, USA, Australia, Singapore, Saudi Arabia. I guess you can all read the list there. Been around a bit. Done quite a bit on expert witness cases, Clear Channel, currently advising on the latest Hillsborough analysis for crowd safety, and done quite a lot of wide area event planning for cities. So what we're going to focus on today is some of the aspects of being able to look at citywide planning. So the outline of this particular talk, we're going to look at 5 key elements. First of all, spaces, and we're going to do some examples from Manchester, Leicester, London New Year, and the Love Parade both in Berlin and Duisburg. We'll look at times, which primarily are the arrival profiles. Over what period of time do the crowds arrive at an event? And we'll look at 2 examples there, London New Year and Love Parade. We'll look at directions, the direction at which the crowd approaches a site, and the 2 examples that we'll illustrate there are Manchester and Love Parade. And we'll look at flow rates, and this is basically how to assess the amount of space that you require both for the arriving and the departing crowds. So in many instances we need to consider spaces, how spaces fill. So calculating the spaces and the queue sizes, very important aspect of this, and we will give you an example spreadsheet, a contingency plan that we work on our workshops so that you've got an example of how to use a spreadsheet to assess queue spaces and queue sizes. And finally, we'll give you a brief overview of some of the real-time decision support tools that we use. There are 2 ways to monitor crowds, density and flow. So if you can monitor the flow rate into a site, you can assess how quickly the spaces are going to fill. If you can't monitor the flow rate, for example, it might be a wide area with multiple entry points, then understanding density and density build-up is the important aspect of being able to monitor crowds in real time. So real-time decision support tools. And to give you 2 examples from installations that we've put in over the last few years, the London New Year event, which has been installed for 6 years, and some of the work we did on the Royal Wedding in 2011, the Royal Wedding planning for that, which was density-based. Now the model we tend to use for these environments is called the dim ice meta model. And that's basically a generic template, and it fits all types of events. So we're going to talk you through how we do that initial type of model. It's now in the latest edition of the UK Event Guide, and part of what we're going to be doing here is describing how this ability to describe an event in a standardized template allows you to compare and contrast various events. And the examples we're going to use for space, time, and direction flow show you how to analyze the potential for risks in these wide area spaces. So, we split an event into 3 primary phases. Ingress. And ingress is obviously related to how the crowds get into a system. queuing systems, barrier systems. It will involve some form of information. It might be printed on tickets. It might be publicized in various multimedia formats. How do you get to the event? What are you expecting to be able to do at the event? With management processes, the arrival profile, the rate at which crowds arrive over time. The modal split, which is basically the different modes of transport the crowd will use to get to the site. So that might be buses, trains, cars walking up from local areas. And flow rate, the rate at which the crowd arrives at a site. So ingress has some analysis. Circulation, mid-event, that's when we look at site and facility planning. So we look at the management of resources on the site, front of stage, concession stands, toilets, for instance, information signage, how the crowd moves around the site once they're in place. So that's the second phase of an event, ingress and then circulation. And then finally, we look at egress, getting out. What are the times it takes for the crowd to leave the site under both normal and emergency conditions? Now, the one thing you have to understand is the event plan must consider an emergency during ingress, an emergency mid-event during circulation, and an emergency during egress. You may have an incident as the crowd are coming towards the event. Now, that's a very different type of management process to handle that and handle the crowd than it would be if you were mid-event and had to facilitate an evacuation. You may also have an incident as the crowd is trying to leave an event. Now, these three different phases may require three different management plans. And whenever I'm asked to look at an event plan, one of the first things I look for is have they considered an emergency or an incident during ingress, because that has a very different type of dynamic. You can imagine people are queuing to get in, they're caught in a queuing system. The barrier system itself may represent some inhibitors for getting crowds out and away safely. So, emergency plan for ingress, an emergency plan for circulation, and an emergency plan for egress. It's all common sense when you point it out, but rarely do I see event plans that have three separate emergency or contingency plans for these three separate phases. Amongst all of this, we need to look at and understand crowd behavior under both normal and emergency situations. So there's a behavioral layer that sits on that, and that will be the subject of some further webinars. At the moment, we're really going to concentrate on the event and look at space, time, direction, and flow. And we can influence the crowd, and there are three different ways in which we can use facilities on site. So the design, obviously, will influence crowd behavior. We may have the types of barriers we use, the capacity of the site, the streets, the roads. What ingress flow rates are really dictated by the design of barrier system you might be using. So area and density around the site, delays around the site, these are all design elements, and design will have a significant influence on crowd behavior. Information has also a significant influence on crowd behavior. So the type of communication system you're using, whether they're Twitter feeds, multimedia messages, what signage, what PA system you're using, how you're making announcements, and the various ambient noise that might be around, maps, plans, diagrams. There's a domain of information that will influence crowd behavior. And finally, management. Now, we talk about management in the context of process and procedures, protocols, communication systems. How do we interpret what's happening within the crowd and use that information to keep the crowd safe? So we look at things like chain of command, operational orders, and particularly red flagging procedures. How do we red flag that something might not be going exactly to plan? And we'll show you how that integrates within the model in a few minutes. So normal and emergency conditions, very important to understand that we have these three primary influences on crowd behavior: the design, the information, and the management layers. Now, I often look at event plans and say, how is this type of information captured and presented? So diagrams, maps, plans, risk mapping to location and time, because risk is a dynamic. The risk during ingress may be, and again, I'll focus this specifically on crowd risks, but the risk may be during ingress at the entry point. Mid-event, that risk has now changed. It's moved in location and it's moved in time. So how are you capturing the dynamics of risk? We find standard risk assessment has a number, That number is read and interpreted, but that number might be something that is highly variable during the event. It might be a high risk at ingress, and then in the entry system, there's no risk because there's nobody there. That risk may change, and how do you map that? How do you capture that type of information? Now, one of the ways in which we do this is to use the dim ice meta model. And there's a summary template. It's blank because we've yet to fill in the nature of this particular event. The beauty about this particular approach is that it allows me to compare and contrast two different crowds at the same venue, or the same crowd at two different venues. Because what will make that particular site unique is what you fill in the boxes. So for the ingress under design, you would fill in the type of bar system, any potential risk you might have, and you start populating the model with a description or with a numerical analysis or a diagram, anything that actually relates to that particular phase of behavior. And again, we tend to look at two different templates there, one for normal, one for emergency. So that really is a meta model. It's a blank template that fits all events. And here's some examples from the BA Honours students in this year's cohort at the university. So you'll see there on the screen how they've populated their particular template. So we have on the left, middle, and on the right, three different event descriptions which describe the type, the context of a particular event, and what the delegates have done is they've coloured boxes. So our eyes are drawn red, orange, and green, or red, yellow, and green in the middle, so that we can see the red areas are the ones that we need to pay particular attention to. So management for egress in the middle section there, where you can see there are some issues, and there's a description of where that particular problem is. So what we have done is we've been able to identify when the risk is, this is during the egress phase, and what nature of that risk is, whether it's design, information, or management, under both normal and emergency conditions. So these templates allow us to identify the dynamic of risk. It's a qualitative measure, but of course the descriptions can be, in this instance, a few paragraphs. It can become part of the event plan. And whenever I design event plans, I tend to always break it down to ingress, circulation, and egress, and during each of those phases, a normal and emergency plan, and how design, information, and management influence the crowd behavior under normal and emergency conditions. So there's a starting point. These are the templates we use for the event description. Now, the event itself has a dynamic, and how do we capture that type of information? Is this descriptive process. So we look at space, direction, time, and flow, and I'm going to walk you through some examples of how we do this. Spaces, for instance. The first questions we tend to ask are what spaces are used? How are they used? I tend to differentiate spaces, and again for the crowd, into two different categories, walking spaces or standing spaces. We tend to look at time. Over what period of time do the crowds arrive or depart, so the arrival and departure profile, and then what elements may change the arrival or departure profile. So what might influence the arrival of the crowd? It could be weather, it could be transportation delays, and how do we contingency plan for a change of the arrival profile? Because if we have a lot of people coming in over a very short space of time, that changes our risk. It might change our management strategy. We look at the direction. Which direction are the crowds coming from and going to? So things like transportation hubs, where are the terminals, the bus terminals, the trains, where's the parking facilities, where are people likely to walk to, and which direction are they approaching the site? And then finally, flow. We tend to look from there on how quickly some of these key spaces fill. So what queuing spaces do we have available, and how do we anticipate the crowd up in those areas? Now you have to remember that crowd flow rate will vary with crowd density. High density crowds tend to move a lot more slowly, and we do have some video clips on the website where you can download those and repeat the experiment that we do, which basically is a piece of string with 1 square meter, and start filling people in that and getting them to walk up and down. So people really understand this relationship of flow and density. Okay, so typical city-wide event questions. Over the last 10 years or so, the question that normally gets asked at this point is, well, we don't know how many people might come to the event. So what's the best way to plan for major events in city centres? Well, the first question I generally tend to ask from that is, what's your event capacity? So that's our spaces question. What spaces are going to be used? From there I can analyse how quickly those spaces might fill. So I look at the time and the rate at which those areas are going to fill. So that's our time and flow rate question. And then what directions do the crowds approach and depart the site? So there's my direction question, transportation hubs to and from the event site. So whenever people ask the question, you don't know how many people might be coming to the event, and the best way to plan for it, then it's back down to spaces, time, direction, and flow. Those are your key elements that you need to understand. And then finally, how do you monitor or measure the crowd build-up as the event's happening? So that's the bulk of this particular talk. Is going to focus on those kinds of questions for citywide events. Now, nearly all of the work we do is focusing into the 4 pillars of crisis management: anticipate, prevent, respond, recover. And we focus very much in these 2 areas, anticipate and prevent. So we do quite a little bit of work in terms of being able to analyse incidents, and emergency management is going to be one of the subjects of a later webinar. So really we're going to focus just now on anticipate, prepare and prevent incidents. Key element towards that is to use these 4 elements of analysis we were talking about earlier, so spaces. And the examples we'll look at just now are Manchester, Leicester and the Love Parade both in Berlin and Duisburg. So let's have a look at Manchester City Centre. This is going to be the Victory Parade, where Manchester United are come through the city centre. First of all, I pull up a Google Earth image, and then on top of that, I just draw out the route that the crowd is expected to move from. So it starts up at the top right there and moves down to Old Trafford in the bottom left. From Google Earth, I can measure the length of that route. I know the crowds are potentially going to be on both sides, so I have an initial estimate of the numbers. Now, obviously, a little bit more sophisticated than that, but there's my first pass analysis. How many people can that route accommodate? I have a whole range of tools, and I think Google Pro allows you to do this. There are a number of tools that allow you to measure area, but I tend to measure the sort of spaces. So I walked down the site with the police. We've looked at where the crowds have typically accumulated in past events, and you can see the profile there gives me a good idea of where I'm going to have high-density crowds. So I do it at 2 people per square metre, then again at 5 people per square metre. I walk down the entire route and section by section. I can actually analyse each and every one of these spaces. So walking down section by section at 2 people per square metre and at 5 people per square metre, we have tools that allow me to analyse the spaces that are used and get an estimate of how many people could be in those key areas at 2 and again at 5 people per square metre. So just stepping through these particular areas, we can see as the model progresses, I've mapped them out in different densities across the entire route. So these are the areas we know from previous events have had high density crowds. What we're going to do first is analyse the space and give ourselves a good first pass approximation of how many people might arrive at the site. So there we are at 2 and at 5 people per square metre with an approximation if the entire road were used. However, we want to run a bus down the middle of it. So we're going to put barriers either side of the road. In other words, let's lose 30% of that available width, that available area for roads and barriers. Now this is an approximation, but it gives me my baseline figure, between 50 and 126,000 people. If I know from previous events there were more arriving in that area than planned for, clearly I'm now starting to raise a flag that my space might not be big enough. So I need to think about how to manipulate the crowds around those areas. So we'll come back to Manchester shortly, because this is obviously, first of all, looking at spaces. In our next section we'll look at directions, times and flows. Let's take another example, Leicester Caribbean Carnival. We run a workshop here at the Emergency Planning College, and 2 of the officers had come on the course and said they had an advice against meant they didn't feel this particular site was suitable. What had happened is that it's been running in Victoria Park for a number of years. Low Images saw a very successful event. Between 60 and 100,000 people attend the event. So what I'm going to show you is just using PowerPoint and Google Earth, we can understand some of the dynamics of the space. So this particular image that's going to come up on the screen in a second shows Victoria Park. And again, what I've done is I've mapped out the site. I can see that it holds 60 to 100,000 people quite easily. It's 90,000 square meters. So there's two spaces. It's just over one person per square meter at peak. And of course, what they want to do is they want to move it into the city centre. So first of all, do we have the space? So again, I can use Google Earth for that particular image. There's my city centre. I can now put an overlay. And using the overlay, I can estimate the area. So it's about 10,000 square meters in that space. However, they also want to have concession stands. So now we've lost some space. We've gone down to 8,400 square meters if we take out the market stalls. And they want to run a parade through that area. So now we're down to just 7,000 square meters. So that's the available space for the crowds. Now, at this stage, a mathematician would look at it and say, you probably don't have a good fit. But we need to communicate this across to the city councillors. So one of the key elements we need to do that is how do we best communicate our areas. And again, a relatively simple technique using just Google Earth and PowerPoint, model the site. So there's the site in Victoria Park. Here's the site now to the same scale, side by side, these two areas, so that we can now see Victoria Park, where it's been held successfully, and the area they want to try and move it to, a city centre. So mark it out in green, the area there, so we can highlight that. And they effectively want to try and move that into this space. Now, I think just anybody would agree, just by looking at that visual, you can see, hang on a second, this isn't going to fit. So, using simple PowerPoint graphics, visuals doing all the work, and this is what I would call a mathematical model. It's a representation of a complex situation using the simplest possible graphics. And that's where it's at. Basically, the site was rejected. The event wouldn't fit into that space. That space was not, as we would call it, not fit for purpose. We couldn't fit that crowd into that area without having a whole range of significant concerns. But in order to communicate those concerns, the simple graphic does all the work for us. So these are modeling tools using readily available off-the-shelf techniques. You don't need any special software. Just need the ability to visualize the key elements of the site. Now let's have a look at Love Parade, both in Berlin and Duisburg. Now, I'm only going to use the minimum amount of information to evaluate spaces. So first and foremost, what do we know about previous events? So Love Parade has been running for a number of years. And there's an image in the center of the parade area in Berlin. You can see that appears to be quite a large area. We see some trucks down in the middle of view here, so we have some idea of scale, we've got some idea that there is a large crowd in this space. Next thing we want to have a look at is some of these other images that look at the approach routes and where the parade route moves down. So we can see there, again, stretching off into the distance, huge crowds, and we have a look in the opposite direction, again, we can see huge crowds stretching off into the distance. So, in all, this is a very large, complex site, very heavily attended, with floats moving through the crowds. Let's have a look at that on a Google Earth image. So there we go. We're going to pull up the Berlin map and overlay onto that just a couple of simple graphics, simple lines to show that area. Now, of course, it's in the middle of a huge park, so we'll look at the approach routes in a second, but they wanted to change that site. So we know its density. We've got the photographs, we've got the intelligence, we can see the layout. This is the Duisburg site. And of course, what they're looking for is they're going to try and move the parade around the center of this area. So the crowds are going to come into this space, and they want to move the parade around the central unit. So this is an old derelict site of a railway cutting, so limited access. But now we have a contained area rather than a huge spread out here. So immediately we'd start to look at those kind of environments and say, Are we introducing some additional risks? Okay, having defined now our spaces and the various context and illustrations we've given you there, let's have a look at times. And one of the key elements we need to understand across that is our arrival profile. Now, the arrival profile is the rate over time at which numbers of people are arriving at the site. And we may have a number of different modes of transport, buses, trains, walk-up. All of these will contribute to the overall crowd arrival. So we can derive an overall crowd from these different modal splits. So train, bus, car, walk-up. And the second thing we need to consider is, of course, the nature of a particular event might change the way in which crowds arrive. For instance, down in Brighton there's an event which is a parade, and the parade finishes at the event site. So we end up with a huge amount of people arriving over a very short space of time. That puts a totally different demand on the design than an event where people are walking up to an event site or coming in by buses and trains. Concerts, they may arrive early for best views, so walk up from pubs, club, other standing seating. There are many factors that can affect the arrival profile. One of the key elements we tend to look at in site design is, okay, you have your history of the arrival profile, but how might the circumstances on the day change that arrival profile? A road traffic accident, a delay in the transportation system, even changes in the weather or anticipated changes in the weather may dramatically change your arrival profile. So just understanding what it is, how it can change, gives you this element across time of the arrival and movement around your site. So here's some examples again from the BA Honours students who've looked at mapping their site out for modal split, the rate at which crowds are arriving on their site, and starting to gather information in order that they can help better prepare and plan for future events. Now, one of the key sites we've worked at, and the illustration we'll give you shortly, is London New Year. So obviously that's an event that holds, I think, 186,000 on site footprint, and there's the footprint there in the red-blue areas. So here's our progressive traffic closures for the 2010 event. So these are the areas we've got catchment, we've got London Underground, who can discharge vast amounts of people to this particular city centre. So we map the site out. And the key things we tend to do first on that, as you've just seen the exercise we did in Manchester, is to actually calculate on each of these areas its available space. So now we have spaces, now we can work out the capacity at 2 and 5 people per square metre, how many people we can get in those areas. In the control room, we actually have an ability to record people approaching the site. So on key locations, in different zones, we have a statistical sample. We have somebody out on the roads with a clicker making a count of people that pass that particular line in a minute, and they do so every 15 minutes. Now that's enough data for us to predict when that space is going to be full. So recording it at 9 o'clock on the example here, using the previous arrival profiles, we can see when the space will be filled. For instance, around about 11 o'clock. So this particular year, when we did this analysis, we had a 2-hour advanced warning that that space was going to be full at 11 o'clock. This gives us plenty of time now to consider how our information system works with the crowd. So as we know the space is going to be full at 11, if it continues to fill at that rate, then communication with the crowd is important. Our capacity of people that want to get to the event grossly exceeds the capacity of people that can enter the event. So we have a limit of 186,000, potentially 1.2 million in the catchment area could come to the fireworks. So it gives us advanced warning on the evening, in real time. It's a real-time decision support tool. Depending on the rates of fill, we can then take different management strategies. So all of this goes through desktop planning exercises, but at any point in time, we can put out station announcements. The event is now full. This will deter anybody that's coming to the event, and it shapes expectations. So take into account the number of people that might be in transit, the number of people that are flowing into the event. We calculate these two numbers together in the control room, done in a pre-coded spreadsheet, and now we can manage the crowd's expectations. We can tell them it's already full in this area or divert them to other areas. Gives us a range of options in order to work with that. If we've got this dimension of time and the arrival profiles, we can develop a lot better real-time command and control for our event. Now we're going to look at directions. So our start of our key elements, and here are the two examples. We'll go back to Manchester Victory Parade, and then we'll look at Love Parade. So our Manchester Victory Parade route, as we demonstrated earlier, if we go back to our Google Earth image, and then we start to map out on the site our route, then we look where are the crowds going to get to this site. So where are our key stations? So let's just highlight those. And we can see, if we draw our 5 key stations there, predominantly they're off to the west, to the right-hand side of your diagram. Now let's have a look at the direction the crowds would take to get to the viewing areas, to the parade. And 1, 2, 3, and 4 there are all predominant to the western side. Now this tells us that if we did have a barrier down the middle, then one side of our space is going to be full, but how do we get people to the other side of the road, to the eastern side of the road? So just by sketching this out, we immediately start to think about our management plan needs to incorporate the ability to migrate the crowds to fill both sides evenly, because I've lost half my capacity if I have a barrier down the middle of the road and I don't allow migration. How are people going to get from the stations to the east? We also note that down at Old Trafford, there's quite an extensive station very close. But between the two, this orange area, there's no immediate rail access. So it doesn't look as if that portion of the parade is going to be heavily populated. It's only really accessible by the locals that live in the area immediately nearby that can walk to it. And you can see to the east there's a river. So now we are looking at how do people get and fill the entire event route. Finally, point number 5 down at the bottom there is Old Trafford itself. Now that's a railway station in very close proximity to an area that's going to be a high attractor, getting a lot of crowds in Old Trafford. Clearly, if we allow that station to operate, that could be a serious issue of both on the way in and crowding at the station on the way out. So it was decided that that was going to create too much of a problem. We'll shut that station down, make sure that everybody's aware of it, and then to arrive by car. So car and coach, it gives us a much better control of that arrival profile. So that's taking a site, that's looking just at the stations, looking at the direction of approach. We already know the spaces, we know its capacity, so now we've got a much better way of assessing if the flow rate, the arrival rate, is going to plan. Let's have a look at Berlin. Back to Love Parade. Now Berlin, as you saw in a previous diagram there, in the city centre, and look at the approach routes. Look at the amount of space that are around those approach routes. So we have plenty of capacity, plenty of resilience in the site that would allow this crowd to disperse through the park, through the tree areas, with lots of different approach routes. It's very resilient. But if we have a look at the similar approach of mapping the site out to Duisburg, you can see there, east and west, and there was only one access route to the site, up and down the ramp. So how do we analyse this? Clearly the two diagrams show us that we've got two very different dynamics on that site. We've yet to identify if there's any risk involved. So back to Google Earth, and Google Earth has got this wonderful facility that allows you to step back in time and look at site over the years. So there's the tunnel, there's the ramp, that's the one route they're taking to get on and off the site. And there does seem to be a little bit of a restraint, a constriction on the site. So let's have a look at the images from 2003 through to 2009. Barriers have been in place for many years on that site. And here's our first image, which goes back to 2003. We can see the barriers are quite clearly indicated there. Now the slider in the top left-hand corner there is a facility within Google Earth that allows you to look back through the history of various sites. And it's quite fascinating to see how sites have developed and moved on. Here's another image from 2005. And we can see there those barriers are quite clearly still in place. Let's have a look at the site in 2006. And again, we can see those barriers are quite clearly illustrated on the Google Earth image. Now let's go forward to 2009. That's a year before the incident. And again, we see another image where we've got a constraint on the ramp. So it seems to be something that's been in position for a number of years. So we need to bear that in mind when we're looking at flow rates. That's the narrowest point system. That's the thing that we might need to calculate around. Now, in order to do that, let's have a look at flow rates. How do we assess the queuing spaces that we might need? How do we take our flow rates with our arrival profile to calculate the spaces, the queue sites? And what I'm going to illustrate now is how we do this using a spreadsheet as a contingency plan. So one of the key elements that we tend to want to look for is how do I take my site plan and develop that into a model, a representation of the site. And this is an example we use from the workshops where we take a site plan and we allow the delegates to try and develop a model of it. So there's a 40-meter egress. It moves north and south at two 12-meter roads. It's one road, but there's a 12-meter section to the north, 12-meter section to the south. We know from data we've collected, approximately 20% are going to go north, 80% are going to go south. We get that information from the car parks that are around the site. So we've got a good idea of how those parks have been filling as to where our percentage distribution of the crowd are going to go at the end of the event. To the south, there's a 100-meter long section. It's 12 meters wide. And then it divides into a road, that red and white indicated route on the diagram to the left, which is our emergency access. So half of it is available for vehicles, and there's a barrier down the middle. That only leaves a 6-meter gap for the crowds to leave. Now, in order to assess this, we need to develop a way of visualizing these egress rates over time. And I use a spreadsheet. It's a very relatively simple technique. Across the top, I tend to put time. So you see 1, 2, 3, 4, 5, 6. These are minutes. So every minute, I'm going to work out what is going to arrive at the various points in the system. So if we look at point A, B, and C at the bottom of the diagram, you see I've highlighted 3 key areas. A is the 40-meter wide section. B is the area where it then turns down into a 12-meter wide section. C is the area that then turns into a 6-meter section. So I state my assumptions down the left, the time progression in minutes. People are passing point A, so it's an unrestricted flow off the site. And that gives me one value of 3,280 people per minute that could theoretically leave site if there were no restrictions beyond it. But you can't fit 40-meter worth of crowd flow. 80% of that is 32 meters worth of crowd flow. It doesn't fit into a 12-meter wide road. Imagine, if you like, you have an egg and you're going to try and push it back into the chicken. It's just not going to fit. So how do we assess the dynamics of this and how it's going to build out? Well, I tend to evaluate each and every section, look at the approaching flow rate, look at the people that can pass through that section, and the difference will be the queue. And the size of that queue will tell me how much space that I need. I can graph this. And here is an illustration of the 3 different types of graphs, taking A on the top, only A into account, free-flowing, 15 minutes to clear the site, 40-meter egress. If we take B into account, it's a 12-meter wide section with 80% of the crowd flow, it now tells me, the peak of that graph, that I'm going to get something in the order of 22,500 people queuing in the system. Now, quite clearly, that's not a rate at which we can move people out. That's the rate at which crowd compression can be building up and risk developing. The bottom graph shows what would happen if we had looked at the site properly and we could see there's only a 6-meter wide gap for the crowd to get out. And just doing a simple calculation, 82 people per meter per minute times 6 meters is 492. 50,000 people divided by 492, 101 minutes, an unacceptable situation for site evacuation. So one of the key elements we tend to look at is how do people visualize this? Well, some people find it very easy on a calculator, some use spreadsheets, some over the years we found use models and flow lines just in order to look at a site and evaluate the potential for risk. So long as you can identify the risks and determine whether the site is working or, in this instance, this site was not fit for purpose, then any of these three particular techniques will allow you to visualize, and more often than not, I tend to use all three. I do a calculation, I'd use a spreadsheet, I'd do a model, and I'd calculate or draw my flow lines in order to evaluate risk. So not using sophisticated computer simulations, most of this we teach, I've been teaching for the last 10 years, very successful to operators, field operators that can go to site, evaluate a risk, and determine whether or not it's fit for purpose. Now let's just for a second go back to Duisburg and have a look at that pinch point we saw. What is predictable and hence avoidable? First of all, there's from Google Earth, that's my site. Here's my pinch point, which I've drawn in yellow, so I've just outlined those areas, and now I'm going to draw the crowd flow. First of all, the narrow point there I can measure, 10.59 meters, and there's the crowd that are going to be leaving the site. At the same time, because it's an entry and exit point, there's a crowd going to be entering the site. Now, quite clearly, if I had a little bit more information, I would know that that system is only going to work up to a point. Thereafter, it's got a significant risk of failing. So these two elements are my space and my direction. What spaces are available, which direction are the crowds moving in. We have, from the various sources of information, time and flow. So this is the graph that they produced in order to assess the site capacity. If you look at the left-hand side of that graph, you see there's a very steep slope. And that tells me that there's a lot of people moving into and off the site in a very short space of time. The steeper the slope, the faster the flow rate. So this tells me I've got a lot of people moving in a very short space of time. I can now work out how many people over what period of time, and will it fit through that available space. So that's analysis. That allows us to analyze sites, and those are the kind of four principles that I tend to take when I'm looking at event plans. The dim ice meta model, space, time, direction, and flow. But in real time, we also need some ability to assess whether or not things are going to plan. So real-time decision support tools include, as we illustrated earlier, the London New Year model, where we mapped out the site spaces and we're monitoring flow rates as people are coming onto the site. I can do statistical samples, I can feed that into a spreadsheet, and then I can see and predict when that space is going to be full. Now that's great when you've got an enclosed site, limited routes and access areas, but if you've got an open site, that particular technique is not the most appropriate tool. So we developed this visual. This allows me to move to any position in a site. I can develop two-dimensional, three-dimensional terrains from this. We can build slopes and we can populate it. I can put, what's it going to look like from camera A. The virtual camera here is set to the same angle as the CCD camera that was going to be positioned to monitor the crowd. And I produced a whole range of visuals, 2, 3, 4, 5 people per square meter, so that the control room operator can look at the visual, can look at his CCD camera and can say, yep, it's reached 80% of its capacity, it looks like this. That's when we need to start instigating control plans. So very useful tool. I can set this up to any angle. If you pop onto the website, you'll see lots of examples that we've already illustrated of sites. So we can map sites out quite easily. And when we developed this tool, we realized we actually had a rather interesting spin-off from it. Now there's an image, which you'll see pop on the screen in a second, of Hyde Park. Now it's an event at Hyde Park, and I can see those little characters moving around, but I can also see the visibility of paths. So I wondered what would happen if we were to map the site out. So what I've done is I've taken Hyde Park in this instance, and this is for the Royal Wedding event, at half a person per square meter. So I can see the paths are quite clearly visible. At 1 person per square meter, I start to lose some of that visibility. At 1.5 people per square meter, it's just visible. And at 2 people per square meter, where my event would be full to the definitions, I start to lose. From this angle, I lose the visibility of the paths. So by using the 3D tool and populating it with crowds, and I can put different densities in different areas, I'm able to assess the crowd build-up. So over a wide area, I've got a good method for open spaces, of both assessing it either in real time with flow or in real time as a density reference. So that's the end of this particular webinar. We are planning a whole range of them for the future. if you've enjoyed it, do please send us information and feedback. We will be able to make the webinar itself available as a download, popping up onto that site and at the Emergency Planning College site. I'm going to put questions and answers on that page, so anybody that's got questions, do feel free to filter them through. Kate and I will process as many as we can. If we can't get them all now, we'll certainly come back to putting these as written comments. In fact, we've loaded this morning's comments on the site already. And if you've got any suggestions for future webinars, please feel free to send those through. So we're ready now for a questions and answer session. Okay. Thanks, Keith. Is CCT key to monitoring crowd problems? From Richard. Hi, Richard. Yes, absolutely. You do need to have a monitoring facility in place, whether it's people that are trained at looking at crowds or a CCT solution, got to be able to look at and monitor crowds. Annie, just thinking about dim ice, there are a number of events where there is no defined phases. Yes, absolutely. Then obviously that creates a separate type of event. It doesn't fit into 3 distinct phases, so mapping it in the same process. But for each section of the event, so it may be, say, a tent or an event space, one of the events that are going on there, there'll be an ingress, circulation, and egress phase. If these overlap, that creates a different type of overlap, and again, mapping those onto site. So very good point there. If they're not clearly defined, again, the map tends to fit it out. So adapting the theory to fit that. I'll send you a separate document on how these dynamic events and other events that you're working at do have an overlapping dynamic, and again, how we split those up. So I will put the answer to that question up in more detail on the web. Richard, you've asked, can I explain more on shockwaves and the effect it creates crush? It was a question that was asked this morning. We run an experiment. We mark a 1 square meter grid in the ground on the classroom, and we ask people to step in and increase the number. So we start off with 2 people per square meter, and then 3, and then 4. And at each stage, as we add another person, we ask, what does it feel like? And of course, as it becomes more and more dense, they become more and more anxious, less and less comfortable. We then give a gentle push onto one of the participants of the experiment, the corner at 4 people per square meter, and you get a little bit of reaction, but very resilient because there's space for people to put their feet out and regain their balance. As you go 5, 6, 7 people per square meter, they can't put their feet out. We now reach the point where a push on the corner will move the entire crowd, like a domino effect. So we see shockwaves coming on at 6 to 7 people per square meter when they're physically touching. Now, one of the key elements about event planning is, of course, you should never allow that in moving parts of the system. Quite clearly, at front of stage, you are going to have high density, which is why monitoring at front of stage is very important. So there are pit crews, CCD cameras, you monitor the crowd's behaviour, the crowd state, and you've got show stop procedures if there's any risk. I mean, we only need to look at the history of things like Roskilde in order to understand monitoring front of stage to prevent crowd collapse. Very important aspect. But when you get a shockwave in a moving part of the system, well, literally our guidance states you never allow that to happen. You never allow the density to get up that high for any length of duration that shockwaves can occur. So if we look at major events and incidents, green guide, guidance, the event guide all state 2 to 4 people per square meter for any moving part of the system. Allowing it to exceed those values gives you the potential for shockwaves to develop. So if we've got the potential of a shockwave, you have allowed that crowd to get at risk. So one of the key elements of this, was this a failure in management? Was this a design failure? Could you have designed the system to prevent high density build-up? How were you monitoring it? Those are kind of the key questions you would ask as an expert witness. Was this a failure in management? Was it a failure in design? Was it a failure in information on informing the crowd of how to move? But shockwaves themselves really only onset between 6 and 7 people per square meter when they're physically touching. Now, quite clearly, that depends on the demographic of the crowd. of Weight Watchers outing down Brighton might have a very different profile than, say, the 14 to 16-year-old anthropomorphically fit British male going to a football match. So the size of the crowd, the demographic of the crowd, that's why these numbers are approximations. But if you ever allow the crowd to get into a position where they're physically in contact, you have a high risk of shockwave and subsequent injuries. So shockwaves here are a phenomenon of high density. Let's have a look. Any more questions come through? Questions be verbal or via chat? We'll do them via chat. We tried verbal earlier. We had too many people trying to talk at once. It was very difficult to control. Another question from Richard. Can responders cause issues? Yes, absolutely. This is information. How would a first responder tying up on a site affect the dynamic of a crowd? So, again, if it's out of the ordinary, in fact, I was involved in an incident not too long ago when I was in a venue and somebody collapsed, a diabetic that was going into a hypoglycemic shock. Not myself, but someone else. And, of course, the blue lights came out. Fortunately, the 5 first responders in the village were in the hall at the time. But as soon as the blue lights arrived, it attracted a crowd. People wanted to see what was going on. Now, during the incident, when the event was going on, nobody noticed that this poor chap had collapsed right next to them. They thought he was mucking around, maybe he had too much to drink. As soon as the blue lights came onto it, everybody's now alerted that there's an incident going on, and for some reason they want to watch that. So crowd management during an incident can often involve how do we disperse the crowd far enough away in a non-risky environment. So planning out where is your incident, how do your blue lights get to it, how might the crowd respond to the blue lights arriving in the incident, should all be part of your contingency plan. And of course, if your incident happens during ingress, during mid-event, or during egress, you might have 3 different crowd contingency plans to take into account for that. Does that answer the question there, Richard? I think you can reply a text to it or any additional questions that come through.
So we've got time for a few more questions, if anybody has any they'd like to send to us.
If not, okay, thanks Richard, I did answer your question, great. If not, do feel free to email us. We will post questions and answer sessions for these webinars on the site. And if you've got any suggestions for future webinars or had any problem with the technology today, do send us an email so we can improve the process for future events. How would festival migration from stage to stage be managed? Very good point. Glastonbury has been an event that we've looked at a number of times, and there's a big steel tunnel that kind of connects sections of the area. Events in city centres such as the Liverpool Matthew Street Festival, looking at choosing the right kind of tribute bands to make sure that the position of the bands are on intersections which have lots of access and egress routes, and monitoring the crowd movement, but also being able to time the event to anticipate where you might have crowds and crowd migration. So it comes down to planning, and actually planning and analysing the type of attraction a particular event was. Now, that doesn't always go to plan. I think Rolf Harris at Glastonbury a few years ago attracted a huge crowd. Nobody quite expected that. So you must have resilience built into your contingency plan to look at migration from stage to stage. Managing it, first of all, it's design. We have the right space, the right terrain to move crowds from area to area. If not, then you may need to think about terraplace or ground support. Over what period of time do the crowds need to move? So making sure there's enough time between the various event finish and the next event starting so the crowd can move safely and efficiently. And using PA and communication systems to make sure that they're fully aware of the time that it'll take to get from A to B. So information, design, management processes, these are your 3 tools that come into play. Question from Joran. How would you click and count people on an event site with free entrance where people often move in and out of the site again? A couple of issues. We've seen in a number of different ways that people would issue, for instance, Aberdeen and Notting Hill Goose Fair. I believe it, Notting Hill Goose Fair? Goose Fair. What they do is they have rubber bands. And as people on the way in are given a rubber band, those rubber bands are taken off of people on the way out. I start with a site that has 10,000 people. I start with 10,000 rubber bands. And if they walk away and take the rubber band with them, I know my numbers are never going to exceed 10,000. As soon as I empty the boxes and I've got no rubber bands left, I can't allow anyone else in. So take the rubber bands off of people on the way out, provide them, these wrist straps for them on the way in. You've got a method of assessing your capacity at any point in time. So you don't need to click and count, but you do need one method, which has been very successful, is issuing wrist strapped bands, but removable ones. So that they put them on the way in, and on the way out, you have your stewards ask them for them back, and you put them back in the box. You recycle them. So the net effect is, so long as there are bands in the box, you know you've never gone over capacity. Okay, we've probably reached our time. Maybe time for another one or two questions if we have any. Thank you very much for all of the positive comments. We really enjoyed doing this one this morning. It's our first experiment on webinars. Okay, Richard, hope to talk to you again soon as well. There's a number of you in the office listening. Thank you very much from all of us. Yes, I really enjoyed it. Hopefully we'll come down and do some individual assessment on various events as we have in the past. Joran van der, thank you very much. Thank you for joining it. To all of you, appreciate we might have had a bit of a technical difficulty with passwords this morning. We are going to be putting this information on the website. We've got iTunes University reference material now for iPads and iPhones. We're looking at BlackBerry and other platforms to put this information more accessible. I've got 2 books coming up in publication, so there's a cheap plug for my publisher. Any information you want, go to the website, gkstill.com, and we can point you to all of the other reference information. There's loads of guidance, documents. We run a couple of forums, so lots of this information is accessible. Just tune in and do feel free to ask questions as you go through. So thank you very much for listening. That's the end of this webinar, so bye from me.
Bye from me too.
Great, and we'll talk to you again next time. Bye.